All right, so now we're moving on to the last section of this chapter, and that is going to be section 4.6 in your book. And that is going to be probability and counting rules. So now once you see it is probability, that lets us know that we're going to have to start creating fractions to say because we're going to do the total number of outcomes of our events, so the possible outcomes that we can have, over top of the total outcomes. So now that's probability. It's not just going to be finding the total. It's going to be now finding what are the odds of something happening out of that total. So we're going to be creating a fraction here. But by the counting rules can be combined with the probability rules in this chapter to solve many types of probability problems. By using the fundamental counting rule, the permutation rules, and the combination rule, you can compute the probability of outcomes of many experiments, such as getting a full house when 5 cards are dealt, or selecting a committee of 3 women and 2 men from a club consisting of 10 women and 10 men. Or some of the examples we're going to do is finding the probability of you drawing 4 aces when you're picking 5 cards out of a deck. All right, so let's just go ahead. There's a few examples, maybe 5 or 6 of them that we're doing, and then that's it. All right, so the first question is find the probability of getting 4 aces when 5 cards are drawn from an ordinary deck of cards. All right, so what we need to do first then is we're finding the probability, so we know that we're creating a fraction. And in our bottom part, it's the total number of possibilities. So we know we have 52 cards. It does not matter in the order in which these cards are drawn. It doesn't have to go an ace and then an ace, another. It can be just 4 of the 5 cards have to be aces. So that tells us we're using combinations. So it'll be 52 NCR, and we're drawing a total of 5 cards. So that's 52 NCR 5. So that tells us the total number of cards that we are going to be drawing. And that will then equal to 10,000. That's equal to 2,598,960 ways. So there are a total of 2,598,960 ways for us to pick 5 of these 52 cards. So now we need to think about what we want to do. We want to know the probability of getting 4 aces. So that means there are a total of 4 aces in our deck of cards. And we're trying to find the total number of combinations that we can pick 4 of them. So we are going to do 4 NCR4, which when you plug into your calculator, you will learn will be equal to 1, because there's only one way you can pick 4 of the 4 kind. So that will then be equal to 1. And then we're going to have to multiply it by however many other different options we have of picking that 5th card. So when we draw 4 aces, there are going to be 48 cards left over. And we're only picking 1 of them. So there are 48 different options that we can get because we can pick 1 of each card. So that means we need to multiply this by 48. So 1 times 48 will then give me 48. We will need to reduce this fraction. If you plug it into your calculator like this, it will automatically reduce it for you for most of them. And this will give us 1 out of 54,145. All right, so you have a 1 out of 54,145 chance of drawing 4 aces. That's why when you play poker, 4 of a kind is considered to be a very good hand, and it's because of the unlikelihood of it happening. All right, for this problem, we have 4 examples we're trying to do. So I'm not going to show you, I'm just going to jump straight to the answer, because when you plug it into your calculator, which you all should be doing, without the calculator, it's going to be really, really difficult to do these. There'll be a lot of by hand calculations, which could lead to some mistakes. So I would strongly advise you using either scientific calculator or a graphing calculator. But I'm just going to jump straight to the answers after I set them up. So for A, we want exactly 2 defectives. So we have a box containing 24 transistors, 4 of which are defective. If 4 are sold at random, find a probability. So that means in our denominator, for all of these, we have 24 possible transistors that we can pick from. It doesn't matter the order, so it's 24 NCR, and we're picking 4 of them. So in all of our denominator, we're going to have this. We're trying to pick that exactly 2 are defective. So there's 4 total defective. We're picking 2 of them. Doesn't matter the order, so it's 4 NCR2. And then we will multiply it. If there's 4 defective, that means there's 20 total that are not defective. So that means if we're picking 2 that are defective and 2 that are not, we need to find a combination for those that are not defective. So it's 20 NCR2. And then when you plug this into your calculator, it will give you 190 over 1,771. All right, your next one for B, it's that none are defective. So once again, we have 4. Well, let's start with our denominator. So we have 24 total that we can pick from. We're trying to pick a total of 4. We have 4 defective. We're picking a total of 0 this time because it's none that are defective. And then we're going to multiply it by the other, how many combinations we have of the not defective. So there's 20 total for the not defective. And now since we're not picking any of the defective, we need to pick all 4 of these are going to be the ones that are not defective. So then when we multiply this through, we will get 1,615 over top of 3,545 or 42. All right, so since we have multiple events that are happening, we're picking a defective and non-defective. We need to figure out the total combinations of picking the defective and the non-defective, and then we multiply them together based on our fundamental counting principle. All right, for C, that all are defective. Well, when we think about this, there is only going to be one case and one case only where all of them will be defective. So I know my numerator has to be 1 because there's only one time that we can pick 4 where all 4 are defective. So then we will just have to put it over top of the total number of options that we have, NCR 4, and that will then give us 1 out of 10,626. Right? You could go ahead and you could say 4 NCR 4 times 20 NCR 0, but that is going to give you 1 because there's only one time where you can get all of them to be defective. Right? And for the last one, we're going to go ahead and use something that we learned in one of our previous sections. Now we're going for at least one is defective. So if you wanted to find at least one, you would, and you wanted to do it the long way, you would have to go ahead and find, well, we would have to find the combination of picking 1, the combination of picking 2, the combination of picking 3, and a combination of picking 4, because that is finding all at least 1. And then we would have to find the combinations for the defective in the other way. It's going to take forever, and it's going to be way, 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 way too much work. But we learned in the previous section that when we are, because when we are finding at least one defective, if we can find that none are defective, we take its complement. So we already found that none are defective, and that was our section B. So all we had to do then is 1 minus where none are defective, so that's 1615 over 3542, and that will give us a total of 1927 over 3542. All right, so when you're finding at least 1, remember, we're still using what we learned before, that we should find none, and then we take its complement. All right, a store has 6 TV graphic magazines, 8 newstime magazines on the counter. If 2 customers purchase a magazine, find the probability that 1 of each magazine was purchased. So since we're finding the probability, we know that we are going to have a fraction. We have a total of 14 magazines, so it's 14 NCR2 or NCR2, and we are going to then pick 2 because we're picking 1 of each. So that's our total. And then in our numerator, we have 6 graphic magazines, so we would have to do 6, and we're picking 1 of them. And with our newstime magazines, we have 8 of them, and we're picking 1 of them. So we would just plug this into our calculator, and it gives us a total of 48 over 91 for your final answer. All right, a combination lock consists of 26 letters of the alphabet. If a 3-letter combination is needed, find the probability that the combination will consist of letters A, B, C in that order. Because remember, when you have a combination lock, the order matters. So a combination lock is actually a permutation. So it's, even though it has a combination lock and the combination's in its name, it's not really a combination where order does not matter. Order does matter. So that means we're going to be using permutations here. But if we think about this logically, we can go ahead and solve this. So the first thing that we should think about is our total number, our total possibilities that we can have in our lock, because we know we need to have a fraction, and here we need to have our total possibilities. But since they can be repeated and used more than once, we are not going to do 26 factorial. We are now going to go ahead and think about this and say, well, we have 3 different letters that we can choose from. Each of them, we can pick 26 because the letters can be repeated. It can be AAA if that's what we want. So we would then just have to go ahead and do 26 times itself 3 times. So our total possibility is 17,500 576. All right. And how many combinations do we have that can unlock this lock? There's only one. You can't have more than one combination to unlock your lock. So that means the probability, or yeah, I guess the probability of someone picking your lock find the probability of ABC. I'm sorry, finding the probability of ABC is 1 out of 17,576. Or the probability of someone picking your lock just by random is 1 out of 17,576. All right, the last question. There are 8 married couples in a tennis club. If one man and one woman are selected at random to plan the summer tournament, find a probability that they are married to each other. Now, there's a few ways you can go about this. I'm going to go ahead and do it the longer way first and then go through the shorter way after. So we're picking one man and one woman. So we're picking there's 8 men that we can pick from and 8 women we can pick from. So that means there's a total of 64 possibilities that we can have. And there are 8 married couples, so it'll be 8 over 64. So if we reduce this, it means it's 1 over 8. So we have a 1 out of 8 chance of picking a married couple. Rather than doing any of this work, though, with 8 times 8 and having to reduce, there are 8 married couples. So there are 8 total married couples that we have. If we're trying to find a probability that we're picking a married couple, that means it would be 1 out of 8. And it's just jump straight to the answer. All right, either way is acceptable. And that's it for this video, and that's it for this chapter.